I can bring you to learn something, but I can't push you. I can bring the horse to the water body, but to horse I can bring it, but I can't make the horse to drink water. So you can show a person the truth. I can show that, I can describe, or I can show that you can. These are the things you have to learn. But you should be on time. Everyone should be on time. But so that is what you can show a person the truth, but you can't make them think. So it is up to you to be on time and start learning and be smile. If you learn very well, and if it is applied, see how people are smiling. A lot many smileys are there. Different smileys are there. These are the way we people are thinking, and these are the way we people are laughing, and these are the way we people are attending the course. So I am bringing you to the water body. It is for you up to whether to drink or not. Okay, fine. Let us come to our session. So the analysis and interpretation of data is my topic. See, first I would like to start from the basic of chemistry. Analysis and interpretation, it is a somewhat applied chemistry. So why I put this table? This is actually a modified Mendeleev's periodic table. If we know the Mendeleev's model periodic table, then only we will learn everything. This is the start of chemistry. Without knowing the fundamental chemistry, we cannot understand anything. See, here groups are there, 1, 2, then leave the in between groups transitional elements. Then see the 3, 4, 5, 6, 7, and 8. This is the way of that the Mendeleev has classified this one. See, one group, this is the 1, and then comes the second group, third, fourth, fifth, sixth, and seventh, and finally 8. So hydrogen, helium, Mendeleev's put it separately. That is, it is not added to this group. So hydrogen and helium is separate. So from this we can learn that first group is helium, lithium, sodium, potassium, rubidium, cesium. Then second group is beryllium, magnesium, calcium, strontium, barium. And third group is boron, aluminum, gallium, indalium, titanium. And fourth group is carbon, silicon, germanium, stannous, and lead. Then fifth group is nitrogen, phosphorus, arsenic, antimony, and bismuth. Sixth group is oxygen, sulfur, selenium, selenium, polonium. Then seventh group is fluorine, chlorine, bromine, iodine, astatine. And eighth group, helium, neon, argon, krypton, xenon, radon. See here, we can say that if the group, if we know the group name, now in which group the element comes, we can say that the outer orbit of that element is having that much number of electrons. That is the first group. Hydrogen, or lithium, sodium, potassium, rubidium, cesium, then comes the francium also. So this one, outermost orbit is 7. Sorry, outermost orbit is 1 electron. And coming to the 7, fluorine, chlorine, bromine, iodine, astatine, etc. These are having the 7 electrons. Last one is helium, neon, argon, krypton, xenon, radon. Outermost orbit is 8 electron. So the outermost orbit is 8 electron here. What is that? That means once the 8 electrons are occupied, it becomes inert. So every element has a tendency to attain 8 electrons. So hydrogen is having 1, then the second beryllium group is having 2, then the third group boron is having 3, and fourth group carbon is having 4. So for up to 3, it will have a tendency to leave electron. So it will become electropositive. Then 4, either it can absorb, it can take it, or it can leave it. So that is fourth group. It can take this one. Carbon, it is having 4 electrons, so it can either take or it can give 4 electrons. So there is 5, 6, and 7. It will be having tendency to attract electrons. Here this 7th group will require 1, 6th group will require 2, and 5th group will require 3. Then comes the final one, that is the inert gases. So from this, if we know the group, that is the third group, second group, third group, that's it. That is the hydrogen group, beryllium group, boron group, carbon group, nitrogen group, oxygen group, then the halogen group, then the inert gases. Then we can say what is the outermost electron. Then second thing, then you see the period. You can learn hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So just like the beryllium, magnesium, calcium, strontium, barium. That means next periods it comes. Each period comes one more orbit. That means again 8 number of electrons will be added. That's all. So you can say immediately you can think about an element and what will be its atomic number and what will be its molecular weight also. See, this is the group. So here the atomic number is given. Without seeing the periodic table itself, one can imagine what will be its atomic number. That is it. That is why I started with the Mendelian periodic table. You will be thinking, hey, it is analysis and interpretation of data. Why I am telling you about this? Yes, there is something. Without knowing this, you will not understand anything. That is why I am taking from here, from this one. See again, you can see the periodic table of elements. Here you can see the element. Then you can see the atomic number and also the atomic weight also. So here you can see element, this element, that is a symbol, and then what is the name of the element, and then there is a atomic number and there is the atomic weight also. See, everything is given in this periodic table. It is difficult to learn this, but if you start from this first table, that is on the Mendeleev table, it is easy. Which group it comes, which period it comes, immediately you can say what will be the atomic number. Then you can come to the conclusion of the atomic weight. Usually it will be double. Okay, so that is about this one. Why I came to this? Because analysis follows calculations for reporting. Each of us are taking the report, analysis report, and then going for the these interpretations. So first we are concerned with analysis and reporting, and then comes to the what is it, interpretation. So what is analysis? Where comes analysis? Analysis is calculations. That is why he said this periodic table. See, periodic table, we have atomic number and atomic weight, I have told. Then you have to see, in the case of analysis, you should know what is molarity, molality, and normality. What is molarity? 1 gram molecular weight dissolved in 1 liter of the solvent gives you 1 molar solution. So that is the molarity. If 1 molar solution, that means 1 gram molecular weight of a substance, you should know what is the molecular weight. If 40 is the molecular weight of sodium, 40 grams of sodium dissolved in 1 liter of water will give you 1 molar solution. So this sodium hydroxide, if it is so, that's the thing. So that is why you are telling, so if it is barium, it is 17, that means 17. If it is a molecular weight, then 17 grams of barium chloride dissolved in 1 liter will give you this one. So 1 gram molecular weight, 1 gram molecular weight of a substance dissolved in 1 liter will give you 1 molar solution. Then 1 gram mole of a substance dissolved in 1 liter will give you 1 molar solution. That is what is 1 gram mole. That is, every substance will have an Avogadro number in 1 gram equivalent. That is Avogadro number 6.023 into 10 raised to minus 28. So Avogadro number you have to know. Then what is normality? Usually in the analysis part we are using the normality. That is what we see here, normality. That is 1 gram equivalent weight of a substance, 1 gram equivalent of a substance dissolved in 1 liter of a solution give you normality. So these steps you have to know if you want to know about the analysis. Without knowing these fundamental things, nobody can do a correct analysis and give the results. Then the analysis will go wrong. Then what is about the analysis? Precision. How precise your result is. How accurate your result is. That is another thing. Say, I have told about the sampling. How precise your sampling is. How appropriate your sampling is. That depends everything. Then coming to the analysis, if everything is okay, till the analysis part, till the samples reaches the laboratory, if everything is okay. Then the analysis part, how precise you are. That is the main thing. How precise? What is precision? It is usually exposed as the standard deviation. That is a measure of the degree of agreement among replicate analysis of a sample. See, I am analyzing a sample 5 times. If I get five times almost the same record, almost the same result, then it is okay. If I have difference in results, that means there is something wrong. So that is precise. How precise? Or precision indicates how closely repeated measurements agree. See, 10 ml of a solution, you are going to neutralize it. You are adding some 0.025 sodium chloride or 0.025 HCl. It takes 11.1 or 11.2, okay, 11.3 or 11. That means it is somewhat accurate. So how precise? So a measurement's precision is acceptable if its random errors are low. If random errors, if you get 10 ml and next time you are getting 18 ml and next time you are getting 2.5 ml, that means errors are very high. But if you get 11.1, 11.2 or 11, that means 11 plus or minus 0.1 or 2. That is errors are low, that is precise. Then accuracy. What is accuracy? Estimate of how close a measured value is to the true value. True value we do not know. We are trying to find out. We can never come to the exact true value. Okay, but how far near our calculation, how far near our result is near to the true value. It includes expressions for bias and position. How biased my result may be, we have to say. If I am telling this substance, this water contains 25 milligram per liter of chloride, I have to say 25 plus or minus 2.5. That means it may contain 27.5 or 22.5 milligram per liter chloride. I am not sure, but I am telling it is 25 milligram per liter plus or minus 2.5. That much 2.5 is my error. That is my bias, or that is that much precise only I am. That is what it is told. Then uncertain. That is uncertainty. So 2.5 I have told. 2.5 I have told. That is 10 plus 10 plus or minus 2.5. Or 5 plus or minus 2.5. I have told 25 plus or minus 10. Whatever it is. So that is uncertainty. That is I am uncertain. I know the value is somewhat here. In between these two values it may come. That is uncertainty. So we call it as measurement uncertainty, or in technical terms we call it as mu. That is, even when obtained with the greatest possible care, every measurement has errors that ultimately are unknown or unknowable. That means I am telling I have got this 15 milligram per liter chloride plus or minus 1.2. That means 1.2 is my uncertainty. So 15 plus 1.2, that means 16.2. Or 15 minus 1.2, that means 13.8. So the values in between 13.8 to 16.2, that is what I am telling you, when 15 milligram per liter plus or minus 1.2. So that is my uncertainty. I am telling you, this uncertainty, I am giving the result. So I have to say this uncertainty also when I give a result. So those errors collectively result in what is called measurement uncertainty. Then second, measurement error. Measurement error is the actual unknown deviation of the measurement from the unknown true value. That is, true value is still unknown to me. I don't know what is the true value. Exact value I don't know. So the deviation from the unknown true value, that deviation is unknown. See, I am observing a color. Suppose I have some color blindness. I am taking a water solution and looking into it. I am telling it is having 10 APC. Another one is telling it is 11 APC. Sir, no, it is 5 APC. That means it depends on the person's perception and his eyesightness and his color blindness. So it is unknown. So it is unknown deviation of the measurement from the unknown true value. So measurement uncertainty is the state of knowledge about this unknown deviation. The unknown deviation also to be taken into account. It is defined as the uncertainty expression. See, detection level. Every time we have to say the detection level. I should know, if I am an analyst, I should know what is my detection level. What are the detection level? The different level of detection level are there. Instrument detection level. Suppose I am using this spectrophotometer, or I am using the atomic absorption spectrophotometer, atomic mass photometry, whatever it is, or HPLC, whatever it is. Instrument will have a detection level. I should know what is the minimum detection level. Then second, lower level of detection, that is also called the detection level and level of detection. What is the detection level of that method? Then method detection level. Every method is having detection level. Then the reporting level. I'll be telling, I'll be reporting with the 2 decimals or 5 decimals or 1 decimal, or I'll be reporting complete view only. So then level of quantification of the minimum quantifier level, what is that? Then minimum reporting level. So all these things you have to keep in mind and say detectable what level what is. In many of the reports I have seen, nobody has told the uncertainty level, or nobody has told the minimum detection level. Sometimes it is like written as BDL, below detection limit. I don't know what is below, what is their detection limits. Method will be having some detection limit, but when I am doing in my laboratory, what is my detection level is I have to do with my experiments. So it is to be reported. It is not seen reported unless otherwise the report of the result cannot be said as accurate or precise. Then analysis. See the analysis. Analysis part, see what are so many methods of analysis are there. What are the different methods of analysis? Titrometry. So you know titrometry. Everybody knows titration. Different types of titration are neutralization, reaction titration is there, complexation titration is there, precipitation titration or neutralization. Suppose I am taking an acid and I am adding the methyl orange or the phenolphthalein as indicator, then adding the alkali or something. So they neutralize when the acid gets neutralized. The phenolphthalein is having color in the alkali, but it is colorless in acid. So in alkali, I am taking in a burette, adding the phenolphthalein, then adding the acid one by drop. At a moment, the color disappears. That means alkali is fully neutralized. So neutralization titration. Then complexation. What is complexation? In EDTA titration, you know EDTA, ethylene diamine tetraacetic acid. They are the hardness when we are determining. It is having a complexation titration. It forms a complex with EDTA. Then precipitation. What is precipitation? In chloride also we are doing the titrometry. What is the chloride? In the water sample you are having will be having chloride. There you are adding the silver nitrate and also with the silver chromate as the indicator. So the silver chromate is having yellow color. When this we are adding the silver nitrate acid into the titration, the silver nitrate reacts with the silver chromate. And when the silver chromate finally is completed, then further chromate is not there, it will start reacting with this chloride. Then silver chloride formation will be there, white procedure will come. That means just to decrease the appearance of the yellow color. So that is the precipitation. Then gravimetry. For the sulfate analysis, we can do gravimetry analysis. So, say take the sample and the barium chloride, barium sulfate will be becoming a precipitate. That precipitate, we can filter it out and take the gravimetric analysis. So, 100 ml of the sample, this much barium sulfate is got, then calculate how much sulfate is there in a barium sulfate. So, gravimetry is there. Then conductivity. Conductivity is also a potentiometric one. Conductivity is using the potentiometric method. That is, we are measuring the conductivity using the conductimeter. It is a potentiometric method. Then nephelometry is there. What is nephelometry? Nephelometry is, we know the light has got three properties. One is light will reflect. Then second is light is refracting, and another is light will pass through. It will one is the reflection, second is the refraction, and third one is deflection. So this nephelometry means light particles when pass through colloidal particles, it will disperse. That is the deflection that is used in the nephelometry. Then turbidimetry is also the same thing. Then potentiometry I have told in the conductivity of the pH meter also. Then discolorimetry. What is discolorimetry? Colorimetry we know when some substances are added to some samples and it develops color, and that color is measured in the measured in the spectrophotometer using monochromatic light. You should know what is the principle behind the spectrophotometer. It is using the monochromatic light. When monochromatic light is passed through a colored solution, it absorbs, and whatever is it absorbs, the absorbance will be proportional to the color of the solution, and what is coming out, you will be measuring that. So here decolorimetry, that is in fluoride analysis. In fluoride analysis, when we add the spadons, the color of the fluoride, color of the spadons reagent will be in indirect proportion to the concentration of fluoride. So this is this calorimetry. Then vaporization technique. Mercury which is analyzed only through the cold vapor technique. That is the vaporization technique. Then the reflex reaction, COD, it is open reflex method. Then is adding potassium dichromate, giving the oxidation, then adding the sulfuric acid, then going for the titration with the ferrous ammonium sulfate, that is there. Then reflex reaction, that is the COD. Then iodimetry in dissolved oxygen and biochemical oxygen demand, we are doing the iodimetry. We call it as the Winkler acid modification method. That is, where to the sample, we will be adding manganese sulfate followed by iron dioxide, and then oxygen will be precipitated, it will react with the oxygen, it will be precipitated, then adding the hydrochloric acid, then equal amount of iodine will be released, it will be backdated with the sodium thiosulfate, that is the iodimetry. Then colorimetry and spectrophotometry, I have told, when some chemicals are added to the components, it will develop some color and it will be measured in the spectrophotometer, wherein monochromatic light is used, IR spectrophotometry and UV spectrophotometry, and invisible range also it is available. Then flame photometry, that means substances have the property that when they are inflamed, when it is fired, it will give different colors. So barium you will get the apple color, sodium you will get the yellow color, and the potassium you will get the lilac color. So this flame photometry is applied in the flame photometer. This is also used for estimation analysis. Then atomic emission spectrophotometry and atomic absorption spectrophotometry, that is atomic level. Then chromatography, gas chromatography, gas liquid chromatography, thin layer chromatography, HPLC. So many things are there. But this is the analytical method I have. You are not in the laboratory now. So you are not going to do any analysis now. So I am not going into the deep of the analysis. How to take, how much to take, how you will analyze the chloride, how you will analyze the sulfide, or how you analyze the nitrogen, how you analyze the there's a vehicle polyform. I am not going to that. But we are interested. That's what I am doing. If you are a laboratory staff, okay, I would have come to each parameter and each analysis method in detail. But come to this point. What we are interested as an environmental consultant, and you are dealing with the EIA, what we are interested. That is what that is what we have to see. Am I audible to everyone?
Yes, sir.
Yes, sir.
Okay. So I think analysis part, now it is not required, but if you are in the laboratory, then I will come with the analysis. Am I right? Am I right?
Yes, sir.
Okay. So now what we are interested. When we are consultants, we are asking the laboratory people, you take sample and analyze these parameters. That is what we are interested. Because we are the people that in the EIA report, we are interpreting the data. What data we need, that we have to decide. It is our duty, or it is the duty of an environmental consultant to see whatever parameters are required for your analysis. That part you have to ask the laboratory people. They have to take the sample, give the analysis. So first you have to know what are the parameters you require. See, usually mainly common things what you will be confused is total gellar nitrogen, TKN, gellar nitrogen and total nitrogen, which is required. Who knows it? I have seen here. You have to do, you have to decide. See, last session I have taken the sample collection and transportation, storage, etc. and so many things I have told in the soil, water, air, etc. I don't know how many people have applied this in your field. But I have seen some people has applied. And Pradeep, I think he asked me personally to share the slide also. See, so many people are interested, so many people are applying. So these also you try to apply. That is what initially I told. I can take the horse to the water body and show the water. I can't make it drink. So it is for you whether to drink or not. See, as a consultant, you have to decide what parameters are good. See, gellar nitrogen or total nitrogen, which is required. See, the total gellar nitrogen is used for the quantitative determination of organic nitrogen. Total nitrogen is for the inorganic nitrogen. So in your water sample, if organic nitrogen is important, you ask them to test total gellar nitrogen. If in your project inorganic nitrogen is important, you ask them to deal the total nitrogen. Why? Because gellar nitrogen contains what is it? Gellar nitrogen quantitative determination of organic nitrogen plus ammonium. In the chemical analysis of compounds, other forms of inorganic nitrogen are traces such as nitrite, nitrate are not included here. But in the case of total nitrogen, see, it is the sum of nitrite nitrogen, nitrate nitrogen, ammonia nitrogen, and organic bounded nitrogen. So it is determined into sample where the presence of inorganic nitrogen is relevant. So if in your project inorganic nitrogen is relevant, you ask them total nitrogen. If organic nitrogen is relevant, you ask for total gellar nitrogen. See, here what is total, see, TKN gellar nitrogen, what is in? It is used as a surrogate for protein in food, feed, and purified samples. So wherever the protein content comes, you ask for TKN. Then knowing the composite nitrogen compounds is essential of water and wastewater treatment plants where organic nitrogen is converted into inorganic nitrogen. So if you are dealing with water and wastewater plants, you ask for the total nitrogen. Got it? That is your application. You have to apply your mind to determine the total nitrogen in soil and in sludges for wastewater treatment, plants for agricultural uses, value of ammonia, nitrite, nitrate, urea, organic nitrogen has to be summed up. So in this case, you need total nitrogen, not the total gellar nitrogen. So you decide which parameter you want. You ask the laboratory to do that. Then gellar method, it gives reliable results if the sought value is the sum of organic nitrogen. Then for the determination of total nitrogen, when the most relevant substances are ammonium, organic nitrogen, nitrate, nitrate, etc. an element analyzer. Therefore, so this is the important thing. Only for telling this thing, I have described all these things. Okay, I described all these things only for coming to this point. So as an environmental scientist who is dealing with an EIA project, you have to determine. So therefore, depending on the type of sample, the purpose of the analysis, you will be deciding, not the laboratory people. And the different substances, the following values are analyzed. What are that? Total nitrogen, total gellar nitrogen, total organic nitrogen plus ammonium. Total organic nitrogen is total gellar nitrogen minus ammonium. Total inorganic nitrogen is nitrate plus nitrite plus ammonium. Total nitrogen is TKN plus nitrate plus nitrite. So you decide which parameter to be analyzed. It is your duty, not the laboratory duty. Then, okay, after analysis it comes results checking. How many people are checking the results? I have seen many reports. You would say pH it ranges from 6.8 to 7.5. It is within limits. Then provided it is 600 and 700 range, it is also okay. What is it? First, you see whether your analysis report is correct. You do some homework. You learn something. If it is wrong, you say this is wrong because of this. You should be able to say how you check the results. So general checks. First, let us come with the general checks. What is it? Total solids should be greater than or equal to total dissolved solids. Total solids, nobody is asking. TDS only we are getting. No need to ask total solids. How we will come to calculating total solids, we will come to later on. Then total solids will be greater than or equal to total set level solids. COD should be greater than BOD. The question will come, sir, whether there is any chance of getting COD greater than BOD? Yes, sometimes. But in exceptional cases, I will come to that point. So normally COD will be greater than BOD. Total coliform will be greater than or equal to fecal coliform. Total iron content will be greater than or equal to ferrous and ferric. Total phosphorus will be greater than or equal to phosphate. I think last 2 weeks back ago, some discussion was going on phosphorus and phosphate. I have seen some discussion in the group. There, somebody asked phosphate or some result came as phosphorus. See, how the report comes, that's the question. Total phosphorus can be reported as P. Or total phosphorus can be reported as PO4. A total hardness can be reported as calcium carbonate. Alkalinity can be reported as calcium carbonate. Calcium can be reported as Ca, or calcium can be reported as CaCO3. Magnesium can be reported as Mg, or magnesium can be reported as equivalent to CaCO3. So many things are reported as what? That's the question. So total phosphorus will be greater than or equal to phosphate. Then electrical conductivity microsiemens per centimeter will be greater than or equal to TDS milligram per liter. Every time keep using the unit. Or the unit, if you do not use the unit later on, you will get confused. Because the TDS it is given microgram per liter. Or milligram per liter, and electric conductivity is given I say microsiemens per centimeter or millisiemens per centimeter. Then it changes. So always keep the unit. So electric conductivity microsiemens per centimeter will be greater than or equal to TDS milligram per liter. Then total hardness will be equal to calcium hardness plus magnesium hardness plus some changes will come because some other hardness, temporary hardness giving substances may be there. Usually it will be like that. Then total oxidized nitrate will be greater than or equal to nitrate and nitrite. Total oxidized nitrate will be equal to nitrate plus nitrite. If pH is 0, then nitrate will be greater than 0. If pH is 0, nitrate cannot be less than 0. Remember, if DO is greater than 7, then ferrous ion will be 0. Because in the alkaline condition, ferrous ion cannot exist. If nitrite is greater than 0, then ferrous ion will be equal to 0. That means ferrous ion will be nil. If ferrous ion is greater than 0, then nitrite NO2 will be 0. It will be nil. Then checking correctness of the analysis. Apply specifically to water samples with a relatively complete analysis. Why I say complete analysis? You cannot say all the parameters that is given in the CPCB guidelines. All the water parameters need not be, but pH, conductivity, total dissolved solid, major ionic and anionic and cationic constituents that indicate general water quality. That is only required. These checks involve calculating TDS and conductivity for measured constituents. See, here you have to say calculating. That is, TDS can be measured, TDS can be calculated. Conductivity can be measured, conductivity can be calculated. So if you want to check the analysis correctness, you should know how to calculate TDS. You should know how to calculate conductivity. TDS calculation you should know. TDS you can do by method. It is only gravimetric. So filter the sample, then do the gravimetric analysis. That's all. Evaporate at 100 degrees centigrade. Then the difference in weight will give you the dissolved solids. So you should know it will come from the laboratory. TDS and there's a conductivity will come from the laboratory. The analysis. Analyze the TDS and analyze the conductivity. But you should know how to calculate conductivity and how to calculate TDS. Then only you can check the correctness. See, add the concentration of constituents in milligram per liter. How to calculate TDS? Total dissolved solids is equal to 0.6 into alkalinity. This alkalinity, see, I have given this star because this alkalinity should be as COCO3. That is why I put it. Alkalinity can be as COCO3, as HCO3, as CO3. So many in factors we can report. So this alkalinity should be as CaCO3. So 0.6 into alkalinity as CaCO3 in milligram per liter plus sodium ions reported as sodium as Na in milligram per liter, potassium as K in milligram per liter, plus calcium as Ca in milligram per liter. Ca can be reported as CO3 also. Magnesium as Mg, it can also be reported as CaCO3. So magnesium as Mg in milligram per liter, plus chloride as Cl in milligram per liter, as sulfate as SO4 in milligram per liter, silicon trioxide or silica we can say in milligram per liter. Silica sometimes most probably sometimes may not be done. So if it is so, you leave it. NO3 nitrate as NO3 NO3N milligram per liter, fluoride as F milligram per liter. You add these things, you will get the calculated TDS. If pH is less than 9, the hydroxyl ionic conductance is insignificant. Less than 9 means hydroxyl ion is insignificant. If pH is greater than 5, the hydrogen ionic conductance is insignificant. So alkaline T2B as CaCO3. This is TDS calculation. Then calculate conductivity by calculation method. Then let us check the correctness. Anion cation balance. Everybody is telling, I have heard a lot many people telling about anion cation balance. Sir, what I am doing? I am anion cation balance. What is that? Sir, it is an Excel sheet. What it says? Nobody knows. Sir, anion cation balance, I have done this. What anion cation balance you have done? What is the formula? Where it is given? Nobody knows. I have seen. You see, you learn anion cation balance. The anion and the cation sums. Anion and cation sums expressed as milliequivalent per liter, not milligram per liter. I have seen lot many people say anion, you take this, cation, you take this, you add this, and both these is anion. Yes, this is anion. Okay, yes, you add this up, you balance this. See. No, it is wrong. Because your report you are getting is milligram per liter. But if you have to check the anion cation balance, you have to take it expressed as milliequivalence per liter. अरे ये क्या है मिली इक्वलेंस पर मैं कैसे ले लूं भाई तो आपको डाउट है ना so milli equivalence per liter you have to take anion and cation sums milli equivalence per liter must balance because all potable waters are electrically neutral so the test is based on the percentage difference is equal to 100 into sigma cations minus sigma anions divided by sigma cations plus sigma anions. Clear? That is milli equivalence per liter. Keep it. Milli equivalence. That is why I put it in color. Milli equivalence per liter. Not milligrams per liter. Your result you are getting in milligrams per liter only. So the typical criteria for acceptance are as follows. That is sum of anions milli equivalence per liter 0 to 3. Acceptable difference plus or minus 0.2%. If it is sum of anions milli equivalence per liter is 3 to 10. Acceptable difference plus or minus 2%. Okay. If it is the sum is 10 to 800, then it is 5%. Okay. How will you calculate milli equivalence? That question will come. I know it is not easy to answer. See, milligram per ion, what is aluminium, barium, boron, or something, it is there. Milli equivalence per liter is equal to milligram per liter into this one. What is the milligram liter in your report? You multiply with this. Milligram per liter, if you have got, it is equal to milli equivalence per liter into swans with these figures. That is for aluminium. If milli equivalence per liter is equal to if milligram per liter, what is your result? You multiply it into this one. Okay. So this is the latest. This table will be useful to you. Anybody has said anything? Any doubt? Next. Measured TDS versus calculated TDS. Measured TDS should be larger than the calculated one. The calculated TDS should not be greater than the measured one. Measured TDS should always be larger than the calculated because the calculation may not include a significant contributor. If the TDS is smaller, if the measured TDS is smaller, then both the higher ion sum and measured value are suspect. So the sample should be realized. Ask them to realize because of this. If the measured TDS is 20% more higher, see I have told TDS, measured TDS should be higher, but it cannot be so much higher. If the measured TDS is 20% more higher than the calculated one, then the low ion sum is suspect. Select the constituents should be analyzed, realized. So we can say which parameter to be analyzed, that also we can say. So the acceptance ratio is the measured TDS by calculated TDS is greater than 1.2. That is 1.2 is less than measured TDS by capital and it is greater than 1. 1 is less than this ratio and 1.2 is greater than this ratio. Clear? Then measured EC versus calculated EC. If the calculated electrical conductivity is larger than the measured EC value, realize the higher anion or cation. The calculated electrical conductivity should not be larger. If it is smaller, realize the lower cation or anion. So acceptable ratio is 0.1, then the ratio less than 0.9 and they see 1.1 is less than this ratio. That is, so 0.9, so calculated measured EC is less than 0. And it is in between, that is in between, we can say in between 1 point. Then measured EC versus sum of ions. Both the anion and cation sum should be approximately 1/100 of the measured EC value. If either sum does not meet the criterion, then it is suspected. Real risk. Acceptable criteria is 100 into anion or cation sum, milliequivalents per, remember it, is equal to 0.9 minus 1.1 into conductivity. Again, calculated TDS to EC ratio. So many methods are there. Calculate TDS to EC ratio. If the ratio of calculated TDS to conductivity is 0.55, then the lower ion sum is suspect. Real ratio. If the ratio is 0.7, higher ion concentration is suspect. So you have to see which is the lower ion, we have to see the higher ion. Then you have to tell this is wrong. So you have to correct it. If the lower anion or cation analysis sum does not change after reanalysis, that may also occur. Realize, but the same it is coming a significant concentration of an unmeasured constituent like ammonia or nitrate may be present. Suppose again the analysis is done, same value comes. That means it does not relate, so that you can say unmeasured constant. You cannot say that your water sample you have got a result of the water sample. You cannot say that this water sample contains these parameters only. Can you say? No, I have asked them to analyze some parameters. So these parameters are this much. That doesn't mean that this water sample contains these parameters only. It may contain some other constants also. So here in this case, you can say it is because of this some unmeasured constant. These are the comments you have to give. In your report, you have to give. This is how you are interpreting. If poorly dissociated calcium and sulfate ions are present, then TDS may be as high as 0.8 times of EC. So poorly dissociated calcium or sulfate. So the acceptable criteria is calculated TDS by conductivity is 0.5 to 0.55 to 0.7. Then measured TDS to EC ratio. The measured TDS to EC ratio should be between 0.55 to 0.7 I told earlier. If it is outside these limits, then either measured TDS or measured conductivity is suspect. You realize. So, these are the things we are checking the results. Before going for first, we have to analyze it. Then we have got the result. Then we have checked for the correctness of the result. Then we are going for the interpretation. So before interpreting, you should know the water and its quantity. Not the water quantity, you should know water. What is water? How is water? Where it is? Why it is? And what are the components? See, it is a measure of the suitability of water for a particular use based on selected physical, chemical and biological parameters. That is what I said. An analysis report doesn't show that it contains only these substances. And analysis report doesn't show that this water every time contains these substances in this rate only, in this quantity only. So water quality is measured in physical, chemical and biological parameters. Physical we are testing temperature, color, taste, odor, turbidity, content of the dissolved solids, suspended solids, cyclable solids. or there's what is the voluntary solids, non-voluntary solids. So many things are there. Chemical parameter is a little measure of those characteristics which reflect the environment with the water it is having the contacts. So these are the what is the hardness, pH, or the BOD or COD, then chloride, residual chlorine, sulfate, nitrate, fluoride, iron, manganese, copper, zinc, so many toxic organic, inorganic substances as well, radioactive substances including. Then biological parameters, these include the bacteria, algae, bacteria, virus, protozoa that are present in the water. On the usually we test for this E. coli and fecal coliforms only. For together we say that total coliforms. Because the fecal coliform is important because the coliforms are important because it comes from the colon. Then we have to say how it has come. We are testing the E. coli because it is easy to identify the E. coli. That is why immediately they give the result. That's why we are testing E. coli. The presence of E. coli means the water is contaminated. So you have to know water, then only you go for interpretation. Without knowing water, you cannot interpret. Water quality is influenced by anthropogenic activities and natural factors also. Always don't say that because of this industrial activity or because of this project activity, this is getting water is going to be contaminated. Don't say because water quality can be influenced by anthropogenic activities as well as natural factors also. Atmospheric pollution, runoff, erosion or sedimentation. Then category of water quality based on different uses and water quality for human use. Example, drinking, cooking. All the water quality for industrial and domestic use, processed water in industries, bathing, irrigation, fisheries. Environmental water quality for the well-being of flora, fauna, ocean, rivers, lakes, wetlands. Impacts of people and high order species which depend on this ecosystem. Elephant drink water, tiger drink water, or other animals drink water. What is it? Major megafauna drink water. So this and also the transfer nutrients to keep up the web of the food web. So there is a rationale. There should be a rationale for interpreting data, water quality. Then there should you should apply a rationale. You should have some reasons. Why? See, biological parameters, fecal coliform or fecal streptococci. Rarely fecal streptococci is done. Fecal streptococci will give you the contamination from the man or animals. Every day you cannot say coliform contamination only by man. No, it can also be through animals also. Only if you go for the total coliform, then fecal coliform and fecal streptococci only give you whether it is through animal origin or whether it is through human origin. So what is the rationale? To ensure low sewage contamination, fecal coliform and fecal streptococci considered as the reflect of the bacterial pathogenicity. So desirable and permissible limits are considered. And it is also applicable with the seasonal change also. Changes in the flow conditions of the water bodies also. Then pH it is 6.5 to 8.5, usually it is good. So the range provides protection to the skin and delicate organs like eyes, nose, ears, etc., which are directly exposed during outdoor bathing. So if the water quality of the surface water, usually I have seen in the surface water quality, it is not told somewhere. But you take the drinking water standard, or you can give the comments now. If the pH is less than 6.5, or if the pH is greater than 8.5, you say. Don't try to bring the values in between within the limits. Tell them to laboratory to let them analyze and give the actual results. Whether results are tallying, we will check it. Then if the results are not within limits, if the results are not tallying, you can ask them to recheck. Or you have to give explanation. This is suitable for drinking, or this is suitable for agriculture, or this is suitable for these water related projects or something. So then dissolved oxygen, the minimal dissolved oxygen concentration of 5 milligram per results, it ensures reasonable freedom from oxygen consuming organic pollution immediately upstream, which is necessary for preventing production of anaerobic gases. So in the case of the dissolved oxygen is less, it will bring an anaerobic condition. So the anaerobic condition is not good. That is, organic contamination will happen. So the organisms, aquatic organisms which are dependent on the dissolved oxygen in water, they cannot survive. If it is the algae or something, it will decay. It will get decayed and the water will be, again the quality will be deteriorated. Then biochemical oxygen demand or the BOD. If it is less than 3 milligram per liter or less, then it is the water considers a reasonable freedom from oxygen demanding pollutants. So these are the things when we have to take care. So by giving the data interpretation, water quality, the rationale you have to give. So these things you keep in mind. And what are the results that if it is not tallying, that also you think about it and give your comments. That is the interpretation of data every time you see. Then one is the water quality index. But I have not taken that part here because it is another chapter we have to discuss with so many hours. Water quality index, if it is so, it will take 2 hours minimum. Water quality index and air quality index. So these are the two things, air quality index and water quality index. This we need to have another session from starting from because see water quality index, it is with that is with the water quality description with the different conditions. How it is classified water quality index values, I have given some ranges 0 to 44, then 45, so 9500. In suppose etc. You can say it is what is the condition of this one. But each parameter, so many parameters have to be related and each importance you have to relate. For example, see, when you go for air quality, that is also another chapter that you have to deal. Based on the measured ambient concentration of a pollutant, sub-index is calculated. So just like in water is also sub-index to be calculated, which is a linear function of the concentration. That is sub-index for PM 2.5 will be 51 at concentration 31 microgram per m cube, 100 at concentration of 60 microgram per m cube, and 75 at concentration of 45 microgram. So this sub value you have to calculate. So how to calculate sub values, it will take another section. So water quality index I have not covered here, and just like the air quality index also. So it is another topic that some other experts will take with another one. Now come to the soil and its quality. Soil pH. See, in our report, I have seen the soil. We are analyzing soil. We are giving the soil quality also. But nobody is giving any interpretation. Nobody is giving any comments on it. Usually say that what is the soil texture. That's all. Finished. And the soil, this pH ranges between these two, and there's a organic carbon ranges between these two. Whether it is suitable or not, that is why. Because there is no standard, so nobody is saying it is within standards. See, you can give some comments. Soil pH influences nutrient availability, toxicities, and activity of soil organisms. pH range, see, less than 4.6, extremely acidic, 4.6 to 5.56. I have given this soil reaction rating. You can say at least this is in between. So the soil is in this at this point, soil is this condition, or at another point is it is alkaline or acidic or neutral. Then you have to say what is it, how you can manage the soil. Acidic soils have to be corrected using lime. Alkali soil to be corrected by using gypsum or sulfur. You can give comment. This is to be corrected. Even if you don't know how much quantity gypsum or how much quantity of lime to be applied, you can say, you consult with an agriculture officer near to your region. But it needs to, you can say. See, soil and plant nutrients. This table will help you a lot. Strongly acidic, see each content, iron, manganese, boron, magnesium, calcium, see, the quantity is given, this much quantity nitrogen. Here comes the strongly alkaline, this component, see. This is effect of soil pH on nutrient availability. This is what I am telling. Medium acid, slightly acidic acid. So here, iron, how much is available? In this one, nitrogen will be available here now. That is in 7 to 7.5. You see, this graph will be useful for immediate soil and quality interpretation. Soil organic matter. Organic matter we are testing. But I haven't seen anybody commenting on the soil organic matter. You should know soil organic. What is the use of soil organic matter? It provides nutrients for soil organisms. It acts as major reservoir of plant nutrients, making nutrient exchange between soil and root of the plants. You know, from the soil, the nutrient have to come to the leaves. From the soil, nutrients are taken above through the phloem. Through the phloem, not the xylem, through the phloem. Through the phloem, it is taken to the leaves, and in the leaves, the photosynthesis happens. You know what is photosynthesis? It is the generation of ADP, AMP in the ADP and ADP in the ATP, and NADP in the NADPH2. The opposite happens during respiration, isn't it? That is NADPH2 is converted to NADP and ATP is converted to ADP and ADP to AMP, etc., etc. So the materials are transferred through the phloem to the leaves. Then only it will happen. So the making nutrient exchange soil and the root of the plants is here. That is soil organic matter is required. So it improves soil structure, soil temperature, influence the soil temperature also. So if we give much water, then it will get decayed, the roots will get decayed. If it is hot in the temperature, if it is so hot, then the roots will be affected. So it maintains the soil temperature, then reducing the risk of soil erosion and increasing water holding capacity. Water holding capacity is a major component that we are testing for this knowing the soil quality. So the soil organic matter helps all in these all things. You can say, seeing the organic matter content, you can give some comments on this. It increases the water holding capacity, or it will decrease the water holding capacity. Whatever you comment you see, seeing on the soil organic matter. Then how can you improve the soil organic matter? Recycling the crop residue back to field without wasting and burning. See, हमने जो देखा होगा ना खेत में जो बनाता है वे सभी आफ्टर इट इज राइस चावल घर पर लेके जाता है बाकी जो है खेत में ही यूज करता है बाकी ऐसा you can see recycle the crop residue back to field without wasting and burning. So applying compost, applying various organic manure, mulching organic waste, using green manure, suitable crop rotation, reduce soil tillage, avoid soil erosion. So all these methods will help us to increase the soil organic matter. So in the soil content, you have to give such comments. Then soil and its quality. Sodium absorption ratio. I don't know how many people have done, how many soil analysis report is having soil absorption rate. It's a very important part. Measure of amount of sodium related to calcium and magnesium in the water extract from the saturated soil phase. Here, calcium is not as CaCO3, it is Ca. Magnesium is not as CaCO3, it is as Mg. In the water extract from the soil, so it is the ratio of the soil sodium concentration divided by the square root of 1/2 of the Ca plus Mg. This is a formula. So if you ask the laboratory people, they will give the sodium SAR. Then with the SAR, you can say SAR allows assessment of the state of localization or dispersion of clay aggregates in the soil. Clay, what is clay? Clay do not allow water to flow down. So it will keep the water there. So it is a clay. So what is the importance of clay? So sodium and potassium facilitate the dispersion of clay particles, so it calcium and magnesium promote their localization. So this is to be tallied with the water, calcium and magnesium, which you are doing in the water analysis. You can see whether it is tallies. If SAR is lower than 3, there is no threat to vegetation. See SAR, simply say, if the SAR you are seeing 3, it is less than 3, so there is no threat to vegetation. You can simply write a comment. If the SAR level is greater than 12, it is a real threat for the survival of vegetation by increasing soil swelling. If the SAR is more than 12, you can give a command. It is likely to cause soil swelling and reducing soil permeability. So increasing soil permeability in order to increase soil permeability, you can say the calcium magnesium ions. Here the clay content you have to consider the clay content also. Sodium and potassium ions facilitate dispersion of clay particles. Calcium and magnesium promote progress. So which to be added, you can say. Gypsum when added to soil or water will increase the calcium concentration in the water. Subsequently, SAR is reduced as the sodium to calcium ratio is reduced. So SAR receives sodium to calcium. So in SAR2, FAR FETB is reduced. See, sodium by calcium by magnesium. So if this figure is increased, that means calcium plus magnesium is increased, SAR will come down. Am I right? Well, this one, this figure, that is a what is it? What is it? This figure. The figure below the fraction. I don't get the name. So the figure below the fraction, if it as it increases, the value will decrease. That is, the value will be inversely proportional to this value. So this increases, SAR will come down. So sodium, less calcium and magnesium, as long as see calcium and magnesium, square root of calcium and magnesium. You should see divided by the square root of 1/2 of calcium magnesium, not this one. 1/2 square root. You have to see. So this has to be much. It increase, this will decrease. Okay. Then electrical conductivity. It is normally considered to be a measurement of the dissolved salts in solution. Soil also I have seen so many conductivity tests you are doing, but now no comments are given. Salt free 0 to 2. You say salinity effect negligible, except for some sensitive crops. Sensitive crops, if it is so, you identify it. In that area, any sensitive crop is there, you have to see. Then slightly saline 4 to 8, yield of many crops restricted. So just like you see. So give some comments on soil quality also. I think this will help you. So through application of gypsum, the saline sodic soils can be amended. So I think this interpretation of data, it is having the data, checking the correctness, and interpreting these data will help you a lot. See, this is what I want to say. I met Money one day. I said, you are just a piece of paper. Money smiled and said, of course, I am a piece of paper, but I haven't seen a dustbin yet in my life. Money is a piece of paper, but Money said, I have never seen a dustbin in my life. But paper will see. Just like, dear friends, I just want to tell you, this what knowledge we have shared here in these slides in the first part and the second part, it will be useful. And it will never seen a dustbin. It should be there in your mind. Keep it. If it is so, try to apply all these things. It will be good. So don't limit your challenges. Challenge your limits. I have seen this an example. What is his name? Deepak. This is Deepak. That capacity of yes, Deepak. I want to specially mention him because he has not limited his challenges. He has challenged his limits. Deepak, see, I have seen, he has done some calculations on the volumetric capacity of a river. He has done a very good job. I think it was a new topic that we are adding in the AA. But he tried a lot and he made a very good report. I have seen it. So I want to mention him specifically. Don't limit challenges. He has challenged his limit and he has succeeded. So let everyone see if Deepak can do, everyone can. You see, you can. So don't challenge your limits and come up with these things. You do this, analysis. You see the analysis report, you counter check it, do some homework and give some comments and you interpret the data. That means the quality of your report and your quality and your importance and your significance and your knowledge goes in. So challenge your limits. That's all for me. Thank you. This is my thank you. So anything else you can ask me? Any doubts?
It's all that's really good with you. This is the lunch.
I request everyone to put on their cameras.
System से करिए ना
Please turn on your cameras.
Anything you want to ask, you can ask. If you don't want to ask, don't ask. If you want to ask in person, you can send message. I think you didn't understand anything. Majority of you didn't understand anything. That is what I feel. Am I right?
Sir.
That's good because it is.
Nair,
I think majority of you may not have understood anything because it is not my fault. It is the fault of the subject. This subject is not an industry, but if you learn and gain knowledge, it will be industry. It will become a passion to gain knowledge.
Nair,
So
sir.
any questions you can ask me, or if you want to message also, that's also okay.
इसके पास इस पे बैठिए नायर सर
Yes.
आवाज आ रही है
हाँ बोलिए.
आवाज नहीं आ रही सर अपन कोई एग्जांपल ले सकते हैं क्या जो काउंटर चेक कर सके लैब की जो रिपोर्ट्स आती हैं अभी उनको किसी का एक एग्जांपल लेकर अपन यहाँ जैसे आपने बताया ना केसन और एनाइन और केसन मेथड से काउंटर चेक कर सकते हैं क्या
कर सकते हैं. कर सकता है, ऐसा कर सकता है, ऐसा करते हैं तो अच्छा है.
तो अभी कैसे अभी आप ले सकते हैं कोई एग्जांपल जैसे अभी कोई लैब रिपोर्ट है उनको चेक कर सकते हैं क्या काउंटर चेक
तो मेरे ऊपर डालता है क्या? अनिल जी मेरे ऊपर डालता है क्या?
सर हम लर्निंग कर रहे हैं ना सर आप बताएं ना.
Okay, Anil ji, वही तो that's a good suggestion. See, in order to maintain the quality of the reports and the quality of these analysis or anything, okay, that's fine. That's very good. So I think that is quality assessment of the quality check section. That is good. One being is good. So check these analysis reports and give comments of something corrected to be corrected. That is also okay. So my viewpoint is that any water sample or air sample or the soil sample or whatever, don't try to get a result in between the limits. Let us get a report what is actual, then we will give the comments why it is so, what is a measure to be adopted. So I am willing, I am ready to check any report. Or I will make a section also. I will teach somebody, make them experts. Then they will do and I will help. That is also okay. Okay, sir? आप मेरे ऊपर डाला ना अनिल जी.
सबसे पीछे बैठे पीछे
Okay. Very good. I will do and I will teach at least 1 or 2 persons. Because it is it will be good now. They will also learn. Okay, sir. Anything else? Anybody? You can ask questions. If anything wrong also you can tell. If anything bad also you can tell. Anything good also you can say. Good or don't say.
सर ये स्लाइड मिल जाएंगी क्या सर
स्लाइड में जाना
स्लाइड शेयर कर दीजिए सर यही
हाँ शेयर कर रहे हैं ग्रुप में शेयर करना तो ग्रुप में शेयर करेगा इंडिविजुअल करना तो इंडिविजुअल करेगा
ओके सर
दोनों पुराना स्लाइड भी शेयर करना पार्ट 1 का भी
यस सर
ओके 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 पुराना स्लाइड प्रदीप पूछ लिया प्रदीप है ना प्रदीप पूछ लिया प्रदीप को दिया सबके लिए दे देगा, ग्रुप में डालेगा, बनाना स्लाइड और ये स्लाइड दोनों. ओके, और कुछ? Try to apply this. It will improve your quality and it will improve the quality of reports. So all of a sudden, even if everything cannot be included, at least try to include 1 or 2 points. That is water. Somebody water can include. Then next time you can improve and come to the air quality. Here, there's a air quality index and water quality index. I have not started. It is another session to look at 2 hours. That is a separate one. So the water, soil, especially the soil also you can see. Soil can be connected with the biodiversity and soil will be connected with the water discharges. All these things it can be connected. So the especially the soil, we have to give some remarks. That is good. Okay. Then.
Thank you, sir.
Anything over? Nothing else?
Okay, thank you.
Okay. Good. So thank you for your patience, for cooperating with me for such a boring topic and a boring person. Okay.
Okay. Thank you, sir.
Bye. Thank you all.
Thank you for the session, sir.
Thank you.
Question पूछा था
सर से अलग डिस्कस करें.
फोटो वाले लेने हैं आपको? ये कर